Okay, so we are going to be starting a new chapter all about exponents. So chapter 7 is all about exponents. And remember that exponents are a way to represent repeated multiplication. So like multiplication is used to represent repeated addition, exponents are used to represent repeated multiplication. So with that being said, let's go ahead and get started. You should have your notes. The first thing we're going to do is just kind of do a little warm-up exercise and remember exactly how we use exponents and how they work. So the very first one we're going to do here is x to the fourth when x equals 3. So if x equals 3, we'll put 3 in right here and we'll substitute it in and we would do 3 to the fourth, which just to remind you means 3 multiplied together 4 times. Okay, so 3 times 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. Okay, and then let's practice this one. The opposite of a squared when a equals negative 6. So this is a little bit more confusing, but I want you to remember that a, or keep in mind that a, the entire variable, is represented by negative 6. So the negative out here stays out front. And inside here, we basically do negative 6 squared. Okay? So negative 6 squared is like this, which means negative 6 times, let's do this, let's make brackets. Okay, so this is a bracket. Negative 6 times negative 6 and then brackets. I know it's kind of confusing, but I'm just showing you mathematically how it works. So negative 6 times negative 6 is positive 36, but this negative out front makes my answer become negative again. So it's negative 36. So just keep that in mind. This entire negative 6 gets substituted in for the a. And since the variable a is squared, it means the negative 6 is what is squared. So negative 6 times negative 6. Just keep that in mind. Okay? And there's our answers, which we've already discovered. Okay, so here's our first key concept. We have 3 key concepts. The first key concept is this. We're going to do product of powers. Now remember, powers are the entire thing, like x squared is a power. Okay, whereas 2 in x, okay, let's look at it this way. X squared is a power, where 2 is your exponent. This is your exponent. Okay, x is your base, or the big number is kind of your base. It's what's being repeatedly multiplied. And the entire thing is called a power. So this is the product of powers. In other words, we're going to be multiplying things with exponents in them. And unlike addition, you can only add or subtract exact like terms. Well, with multiplication, you can do anything. You can do any type of, you can multiply anything together. They do not have to be alike. Okay, so to multiply powers, the one thing they do have to be alike is they have to have the same base to do this. You can multiply anything, but to add the exponents, it's having the same base. Then you would add the exponents. So here's an example. A to the m power times a to the n power. The bases of a are the same. The exponents can be the same, but they don't have to be. So notice our base stays the same and we add our exponents. And here's another example with numbers, and I will show you why. Okay, 5 to the 6th power means 6 5s multiplied together, correct? Okay, and we're multiplying that. So it's still multiplication. We're multiplying that by 3 more 5s because we have 5 to the 3rd. So we're multiplying that by 3 more 5s. Okay, so how many total 5s do we have multiplied together? 1, 2, 3, 4, 5, 6, 7, 8, 9. So my base is 5 and my exponent is 9 for a power of 5 to the 9th power. Okay, does that see? So instead of writing all of this out, we just can see that the pattern here, since this is multiplication and this is multiplication and this is also multiplication, we can just take our exponents and add them together and figure out how many total 5s, as long as my base is the same. Okay? All right, so some guided practice or some examples we have here. The base in this case is 7. Notice the 7 just stays the base. We don't do 7 times 7 and get 49. Do not do that. The 7 in this case is the base because each of these 7s have a power to them, have an exponent. Okay? So we keep the base the same and we just add the exponents. 3 plus 5 is 8. Okay? In this case, my base is 9. So I have a 9 here and a 9 here and a 9 here. Well, this 9 has an understood exponent of 1. In other words, there's 1 9 being multiplied. Here, there are 8 9s being multiplied. And here, there are 2 9s being multiplied for a total of 11 9s. So again, my base stays the same. And I just add my exponents. So 9 to the 11th power, because there are 11 total 9s. This right here, you do not have to do if you do not want to as part of your steps. You can do like I did, as long as you can identify your base, write it, and then add all your exponents. Because there's 1 9 here, 8 here, and 2 9s here for a total of 11 9s being multiplied together. Okay, next example. This case looks a little different, but again, remember it's an understood 1 right here. It's 1 -5 being multiplied, and then 6 more -5s being multiplied, and all of those are being multiplied together, as you can see right here. We don't have to have a symbol. We're just showing you that no symbol is understood multiplication, and no exponent is an understood 1. Okay? So now we have a total of 7 -5s being multiplied together. So we can write out 7 -5s, or we can write it just like this. Okay? If you have any questions about this, please write them down on your notes, and then you can ask them. Okay, this time my base is a variable, and it's okay. My base can be a number, it can be a variable, but whatever I'm looking at is I have something to an exponent times something else to an exponent, or times that same something to an exponent. Just like here I have 2 7s, or really I have 8 7s. And then I have these 3 9s that have exponents. I have -5s that have exponents. Now the x's have exponents. For a total of 7 x's, as you can see right here. Because there's 4 x's here, there's 3 x's here, all being multiplied. That's the key. Everything you see here is multiplication. There's no addition. And we get x to the 7th. Okay? All right. Your turn. So stop the video, and you can do your guided practice. And then you can check your answers. Okay, next key concept. Hopefully you stopped the video to go through those. Stop the video, write the problem down, try it, check your answer. Next key concept is the power of a power. So whereas the first time we were just multiplying 2 items with exponents or 2 powers together, now we're going to take a power and raise it to another power. So to find the power of a power, multiply. So now here's what I want to show you to make it make sense. So now we have the base of A to the power of M, and then that entire thing is raised to the power of N. Now I want you to remember that when you're doing an exponent, it means repeated multiplication. So I will show you on this next example with numbers how that works. Here's the shortcut. We take it and we just do 4 times 2. But let me show you why. We have 3 to the 4th power raised to the 2nd. In other words, 3 to the 4th power squared. This 2 right here tells me to take my 3 to the 4th power and multiply it together twice. Well, you know, that's not too hard to write out. But if my exponent was a lot larger, sorry, that looks like a 4. Let me erase it. If my exponent was a lot larger, that would be a lot of writing. I'd have to write 3 to the 4th times 3 to the 4th times 3 to the 4th, however many times this tells me. And now we just have multiplying powers. And 3 to the 4th times 3 to the 4th is 3 to the 8th. It's a total of 8 3's being multiplied. Well, the shortcut allows us just to multiply those together. So the multiplication just gives us the shortcut of being able to do 4 times 2 instead of having to write it out. Okay, and the reason we can do this is because it's the identical items being repeatedly multiplied. So one thing you can look at is kind of like distribution. Like we can do 2 times 4. Okay, um, it's just going to take practice. And so here's some practice. So now we have 2 to the 5th to the 3rd power. So in other words, we have 2 to the 5th times 2 to the 5th times 2 to the 5th. Okay, and so I could look at it that way. I could write it out. My base is 2, so my base is going to stay the same. And I have 5 2's, and then 5 more 2's, and then 5 more 2's for a total of 15. But my shortcut would let me just do 5 times 3. Okay? And that would be a much easier way. Now, when we multiply, when our exponents are right next to each other with parentheses in between them. We add when our exponents are not right next to each other. The bases are in between them. So when we see a base and a base and a base, that means we add our exponents. Notice here I just have the one base, but I had the 2 exponents together, so I'm going to multiply those exponents because it's a power to a power. Okay, next example. Sorry, there's what they're showing you. I'll just let you make sure you see that. Okay, and the answer is 2 to the 15th. Next example is -6. Okay, so first thing we have to do is identify my base. What's my base in this example? Okay, my base would be -6. And my exponent, this one is 2, this one is 5. So I'm going to do 2 to the 5th power, but my base is going to stay the same. And I'm going to have 2 times 5, or in other words, I'm going to have -6 to the 10th. So notice my base didn't change. All I did was multiply my exponents. Okay, good with that? Write down questions if you have them. Next example, what's my base this time? My base is x. So my base isn't going to change. I'm just going to multiply my exponents. So I get x to the 8th. And the last example is, y plus 2 to the 6th squared. Well, what's my base? Yeah, it's a quantity. It doesn't matter. My base can be a quantity. So there's my base. It stays the same. Notice my base didn't change, just like it didn't change here or here or here. My base will not change. So now I have y plus 2 to the 12th power. And I cannot I cannot distribute that into that parentheses. Okay? All right, your turn. As you come across this problem, pause the video, solve it, check it. Pause the video, solve it, check it. Okay, so if you have any questions over either of these or any of these 4 examples, please write them down and bring them to class. Okay, the last key concept. Power of a product property. We're putting it all together. Here's the example. To find the power of a product, find the power of each factor and multiply. And holy cow, I know that sounds like a lot, but if I show you an example, try to keep it easy. So here we have A and B. A times B. This is a product inside here, okay? This is a product. Now, this product is raised to the mth power, or the m power. So that means everything inside this parentheses, since it's just multiplication, remember this is all multiplication, okay? So since it's multiplication inside these parentheses, I can take the m and I can put it with each term inside there. Now, the example before where I had y plus 2 to the 12th power, that had addition. I can't do that when it's got addition in the middle of the parentheses. This just has multiplication. So I can do a to the m power times b to the m power. Okay, so here's my example. 23 times 17 to the 5th power. I could go ahead with a calculator and multiply these together and then raise it to the 5th power, or I can take my 5th power and put it with my 23, put it with my 17, and still multiply those together. It would not matter the order we multiply in. Okay? All right, so here's some examples I'm going to show you. So my 8, notice the dot is there, so it's multiplication. since it's not addition, I can go ahead and make this 24 to the 8th times 13 to the 8th. And yes, with a calculator, we could go ahead and solve that, but we're not going to. Now, this one looks like a big mess. It's really, really not. And this step to me is confusing. I like just seeing it like this, and I want you to realize that the 2 goes with the 9, the 2 also goes with the x, and the 2 also goes with the y. See what they're doing? They're showing you that. So it's 9 squared times x squared times y squared. In other words, everything inside this gets squared. Everything. Everything inside there gets squared. So 9 squared becomes 81. X squared stays x squared, y squared stays y squared. Okay. Next example, -4 times z quantity squared. So that means my -4 gets squared and my z gets squared. You guys, what's -4 times -4? 16. That is why the negative disappears. I no longer have a negative because my negative is inside the parentheses and it is squared. And a negative times a negative becomes a positive. If I had a negative outside the parentheses, then it would change that. So we just square everything inside the parentheses. Next example, last example. The negative outside shows you the difference here. This negative is not squared because it is not inside the quantity that's being squared. It's outside the quantity. So only what's inside here is getting squared. So this time it becomes 4 squared times z squared, which is 16z squared. However, there's that negative waiting outside the parentheses. So there's the difference in the answers. The negative inside gets squared and becomes positive. The negative outside does not get squared. Okay, again, guided practice. Oh no, this is more example. Putting all 3 properties together. Okay, so look at all this we have going on. You guys, I know it's a lot, but keep it simple. Okay, we're going to keep it simple. So the first thing we're going to do is we're going to use the power of a product. In other words, we have to kind of think of it like getting rid of those parentheses. Kind of think of it like order of operations to some degree. Get rid of your parentheses. So this 2 squares everything inside this parentheses. So we get 2 squared, which is right here. And we get x to the 3rd squared, which is right here. And then our x to the 4th just gets copied down. So now all I've done is take this 2 and I have put it to everything inside parentheses. Is everybody good with that? I took the 2 and put it inside the parentheses, or distributed it, kind of. We don't call it distribution, but it's similar to distribution. Okay, so now the next step is my power of a power, this one right here. Okay, I have to actually now take the 2 times 3. Because this is x to the 3rd times x to the 3rd, which is a total of x to the 6th. So, okay, so as you see with this step, the 2 squared becomes 4. The x to the 3rd squared becomes x to the 6th, because remember, it's x to the 3rd times x to the 3rd. So there's 6 total x's right here. And then our x to the 4th is just brought down. Okay, now it's kind of like combining like terms, so to speak. My 4 is now just a coefficient, and I have 6 x's being multiplied here and 4 x's being multiplied here, and all of these are being multiplied together for a total of 10 x's. So my 2 squared becomes 4, and it just follows on down, and then all of these x's gives me a total of 10 x's. Okay. So here's our guided practice. So you pause and check. Okay, and I'm just going to go ahead and show you this one. I had to do -3 squared times n squared, and -3 squared is 9, and this is n squared. Okay, to help you with this one, I end up doing 9 to the 4th, and then m to the 3rd, all to the 4th. And then my next thing, so I do 9 to the 4th, m to the third to the fourth, and then I do n to the fourth. Okay, and then so 9 to the fourth is 6,561. M to the third to the fourth becomes m to the 12th because 3 times 4 is 12. And then n to the fourth is just there. Now, I don't have any bases now that are the same. Okay, the example we had x's. The base was x. They're the same. This is an m and this is an n. Different bases, so I just leave it just like this. I can just leave it like that. I cannot put the m and the n together and make it mn to the 16th. We can't do that because I have a bunch of m's and a bunch of n's, and they're different numbers. They're different bases. Okay, this last example, okay, I know that some of you are going to want to do the 5 times 5 first, but we have to do exponents first. So just like order of operations, we have to do exponents in parentheses. So the first thing I'm going to do is distribute this. I'm going to let you make sure you do that part first, then find your answer. So pause and find your answer. So hopefully you did this 5 to the 4th and then x squared to the 4th. Okay, this becomes 5 to the 5th. At this point, you can put those together if you want to. You can do 5 to the 5th, and then this becomes x to the 8th. And then once you solve that, obviously it becomes 3,125. That's what 5 to the 5th is, and then x to the 8th. You could leave it 5 to the 5th if you wanted to. It's not totally simplified, but okay. All right. And you can come to class and get your assignment, bring questions, all that good stuff. That's the end of the video.